Unions in Venn diagrams, Introduction. So far we've been building our understanding of sets, what they are, and what makes them up. We also spent some time looking at how sets can intersect, meaning finding the elements that are common to two or more sets. Remember, the intersection is where sets overlap. Now, we're going to move on to another important operation, with sets called the union. Think of union as bringing sets together. Specifically, the union combines all the elements from each set into one single set. But here's a key point. If an element appears in more than one of the original sets, we only include it once in the union. We eliminate any duplicates. And just like with intersections, we can visualize this beautifully using a Venn diagram. When we find the union of sets, we represent it by shading or coloring all the areas covered by the sets involved, both the individual parts of each set and any areas where they overlap. This gives us a clear picture of everything that's included in the union. In the next slides, we'll look at exactly how to do this with examples, starting with 2 sets and then moving on to 3. Understanding the concept of union. So let's move on to understanding the union of sets a bit more formally. This slide introduces the notation for the union of 2 sets, which we'll call A and B. We write the union as a union B, and the symbol for union looks like this, A with a curved line over it connecting to B. Now, what does this union actually mean? Well, the union of A and B contains all the elements that are in set A, or in set B, or in both. Think of it as combining everything from both sets into one big collection. Let's look at an example to make this crystal clear. We have set A, which contains the numbers 1, 2, and 3, and we have set B, which contains the numbers 3, 4, and 5. So when we take the union of A and B, a union B, we combine all these numbers. We start with the elements of A, 1, 2, 3. Then we add the elements of B, 3, 4, 5. But, and this is important, we only list 3 once in the combined set. Therefore, a union B is equal to the set containing 1, 2, 3, 4, and 5. Notice how we've eliminated the duplicate 3. This is a key point to remember. The union only includes unique elements. We'll see how this looks visually in a Venn diagram on the next slide, which will really help solidify this concept. But for now, make sure you understand that the union is about combining all elements, avoiding repetition, and including anything that's in either set or both. Representing unions in Venn diagrams. Let's move on to how we visualize the union of sets using Venn diagrams. As we discussed on the previous slide, the union combines all the elements from each set, getting rid of any duplicates. So this slide explains how to represent that visually. The first point here tells us that in a Venn diagram, to show the union of sets, we simply shade or color in all the regions that are part of any of the sets involved. This is really important. It's not just the overlapping part, but everything. This includes the parts that are unique to each set, and of course, the overlapping region which represents the intersection, the elements they have in common. Now, let's break it down step by step. Step 1 is to draw the Venn diagram. We start by drawing circles to represent the sets we're working with. If we have 2 sets, let's call them A and B, we draw 2 overlapping circles. This overlap is crucial, as it shows where the sets have elements in common. Step 2 is to identify all the regions. Think of it like this. We need to identify the part of set A that doesn't overlap with set B. Those are the elements unique to A then. We identify the part of set B that doesn't overlap with A. Those are the elements unique to B. And finally, we have the overlapping region, which represents the intersection of A and B, the elements that are in both sets. Step 3 is the key. Shade the union. We shade in all of those regions we just identified, the unique parts of A, the unique parts of B, and the overlapping intersection. Everything gets shaded. Let's look at an example to make this concrete. We're given 2 sets, A equals 1, 2, 3, and B equals 3, 4, 5. Now, imagine we have a Venn diagram with 2 overlapping circles. One labeled A and the other labeled B. We'll place the numbers from our sets into the diagram. First, we put 1 In the part of circle A that doesn't overlap with B then, we put 2 also in that same part of circle A next. 3 goes in the overlapping region, because it's in both A and B then. 4 goes in the part of circle B that doesn't overlap with A, and finally, 5 goes in the remaining part of circle B. Now, to represent the union, we shade in all the regions within both circles. Everything inside those circles is part of a union B, and as you can see, the shaded area represents the set 1, 2, 3, 4, 5, which is exactly what we found when we calculated a union B on the previous slide. Remember, this visual representation is incredibly helpful for understanding and solving problems involving unions. We'll build on this concept as we move forward, including when we look at 3 or more sets, which is what we'll cover on the next slide. Unions of 3 sets. So we've now mastered unions with 2 sets, and we've seen how to represent them visually using Venn diagrams. Now, let's take things a step further. This slide shows us that the idea of a union isn't limited to just 2 sets. The concept extends perfectly well to 3 or even more sets. Let's consider 3 sets, which we'll call A, B, and C. The union of these 3 sets, written as a union B union C, includes all the elements that are in A, or in B, or in C, or in any combination of these sets. Essentially, if an element exists in any of these sets, it's part of the union. Now let's see how this looks in a Venn diagram. Instead of 2 circles, we now have 3 overlapping circles, each representing one of our sets, A, B, and C. To represent the union, a union B union C, in the Venn diagram, we shade all the regions within any of the 3 circles. This is really important. Let's break down what those regions are. First, there are the regions that represent only A, only B, and only C, the parts of each circle that don't overlap with any other. Then, we have the regions where sets overlap. That includes the intersection of A and B, the intersection of A and C, and the intersection of B and C, and finally, there's the very center, where all 3 circles overlap. This central region represents the intersection of all 3 sets, the elements that are common to A, B, and C. So, when you're shading for the union, make sure you include all of these areas. Remember, we're looking for everything that's in A, or B, or C, so every part of those circles needs to be shaded. This might seem a little more complex than with 2 sets, but the core idea remains the same. We're simply combining all the unique elements from multiple sets into one larger set. And the Venn diagram is a fantastic tool to help us visualize and avoid any mistakes. In the next slide, we'll look at some common errors students make when working with unions, so pay attention to those to make sure you've really got a solid understanding. Key takeaways. Let's recap what we've learned about unions. This slide summarizes the key takeaways, and it's important you have these firmly in your mind before we move on to practicing more complex problems. Firstly, it states that the union of sets combines all unique elements from each set. Remember, when we talked about sets A and B and found a union B, we took everything from both sets, but we only listed each number once. So, if a number appeared in both sets, it only showed up in our final union set. This is what unique means in this context: no repetitions. Secondly, it reinforces how we represent this visually. In a Venn diagram, the union is represented by shading all areas within the involved sets. So, everything inside the circles, whether it's just in one circle or where the circles overlap, gets shaded. This shaded area is the union. It visually shows all the elements that belong to any of the sets we're considering. Think of it as highlighting everything that's included. Finally, and this is a powerful point, the concept of union extends to any number of sets. We've looked at 2 and 3 sets so far, but you could have 4, 5, or even more. The principle remains the same. Combine all the unique elements from all the sets. In a Venn diagram, you'd simply shade all the regions within all the overlapping circles. This is a foundational concept, and understanding these key takeaways will be crucial as we tackle more challenging problems involving multiple sets and Venn diagrams. Are you comfortable with these 3 points before we move on to looking at some common mistakes students make? Common mistakes. First, it says, forgetting to shade the entire region. Now, remember from the previous slides, when we're finding the union of sets, let's say sets A and B, we're looking for everything that's in either A or B or both. So, when you're representing that visually with a Venn diagram, it's crucial to shade all parts of both circles. Don't just shade the overlapping section, which represents the intersection. Shade the parts of circle A that don't overlap, the parts of circle B that don't overlap, and the overlapping section. If you leave any part unshaded, you're missing elements that belong to the union. Next, we have double counting elements. This is a really common error. Remember, the union is about listing unique elements. If an element appears in both set A and set B, you only include it once in the union. The Venn diagram is actually really helpful here, because when you place the elements in the diagram, the element will only appear in one location, either in A only, B only, or in the intersection. This visually prevents you from listing it twice when you write out the elements of the union. Finally, the slide points out confusing union with intersection. This is a fundamental misunderstanding that can throw everything off. Let's quickly recap. The union, we often write that as a union B, combines all the elements from both sets. It's everything. The intersection, a intersection B, is only the elements that are common to both sets. So, union is about or including everything in either set. Intersection is about and only including elements present in both sets. Keep those keywords in mind, or for union, and for intersection, and you'll be much less likely to mix them up. Let's move on to the final slide, which highlights some common mistakes students make when working with unions in Venn diagrams. It's good to be aware of these before you encounter them in practice, so you can avoid them. So, those are the key pitfalls to watch out for. By being mindful of these common mistakes, you'll be well on your way to mastering unions and Venn diagrams.